Hello, in 2020 a major overhaul of BrainAnnex started. If you look at the change log, it's a long listing. You can scroll down and scroll down and scroll down because the project goes all the way back to 2015. For the first 5 years, BrainAnnex underwent a lot of growth, different versions. And then in 2020, the process of completely rebuilding it from the grounds up started. The page with the versions and change log details all the major changes done to the technology stack, some key technology elements, and the major design changes. In this video, I will only concentrate on a few, namely the fact that now BrainAnnex is built upon the graph database Neo4j, that it's Python based, and it's no longer limited to what used to be in its early versions, which was a multimedia content management system. Now it's much more general tool to deal with any kind of data that's built on top of a graph database. And finally, it's no longer a monolithic web app as was presented in the early videos. Now it can also be used in conjunction with existing web apps, and now parts of BrainAnnex can be used independently. Any part from its technology stack can be mixed and matched as needed. I will talk about a few things today, including background, graph databases, technology stack. But first, let me take you on a little side trip to Fortaleza in the north coast of Brazil. One of the world's largest bank heists took place there. The tunnel under the street into the vault of the central bank, and then ran off with a huge amount of money. However, within a couple of years, the federal police arrested virtually all the perpetrators. How did they find them? This scene is from a documentary as they were closing in on the suspects. What do you see? What I see is a graph database. Hello everyone, I'm Julian West. Let me just quickly mention how I got interested in them, given that my background had been using SQL. But I had a turning point for me several years ago when I was working at a company that was dealing with large biomedical datasets. And something that particularly caught my attention was this research project called Reactome.org, existing knowledge about almost all the molecules inside human cells and then the way they interact with each other in different pathways and the groups of pathways that create systems. And so every pathway that you see highlighted here in the various clusters is, from a point of view of data, is records that are interconnected. It could be very advantageous to be able to follow and discover connectedness between the data and being able to draw conclusions. As far as the Neo4j goes, let me just refer you to an article I wrote. I will post the link, where I explain my experience and I give some examples of situations where you have a lot of connectivity between data records. In this example, directors that direct movies and movies that have actors, and spanning this path is an awkward, really clunky thing to do in a relational database, and it's absolute breeze in a graph database. For example, you want to ask a simple question like which directors have worked with Tom Hanks in 2016? If you've done any SQL queries, then this may look familiar to you. You would be creating a query. You want to select the name of the directors from a directors table, and then this directors table will have to be joined with a special table that links directors and movies, and then we join it with a table of movies, and in turn we join it with a special table to link movies and actors, and finally we join it with a table of actors. And then here we want to specify all the links by matching IDs, and finally we request the actor name is Tom Hanks and the release date 2016. So that's the net result. It's a monstrosity, no other words for it. In a graph database, by contrast, situations like these are just a natural traversal of the graph. For example, let's say that we have the data represented here, where each little circle represents a record. The blue one is actors, the purple ones are movies, and the green ones are directors. And so here we have Tom Hanks, who stars in two movies, Big and California Typewriter. and then each of these movies is directed by a particular director. And then when we ask the question about which director worked with Tom Hanks in a particular year, then we are basically asking to do a graph traversal that starts at Tom Hanks and then ends up to any grid node, director node, provided that it traverses a path that goes through a movie whose release date is that year of interest to us. And that can be expressed with a query, which is called Cipher. That's the name of this query language, where we are asking for to create a match, so a path through in the graph, starting with a actor node, and then following a relationship to a movies node, and then from there following a relationship to a director's node, with a few conditions that the name on the actor node must be Tom Hanks, and the release date on the movie node must be 2016, and then we extract the name from the director node. That's all there is to it. Okay, let's switch gears now, and let's say you're a programmer and you would like to use Python to do something with a graph database. So how do you do it? The company Neo4j provides two libraries to interface with Python. One of them is extremely basic. You can't really do much with it other than extremely simple stuff. The other one, you can do just about anything, but it's very complex to use. It has really involved data types, and it's not particularly easy to use. So to remedy this, I created a library called Neo4j Liaison 2 years ago. And then when I worked at GSK Pharmaceuticals last year, I took that library and combined it with a library that my boss at the time had produced. And we expanded it, and we did a lot of testing. The company made it open source under the name of Neo Interface. And afterwards I forked it, and then I developed it further. And now, as a result, we have this library, and it's called NeoAccess. It's been around for a while. It has been tested in a variety of circumstances, and it has received very substantial amount of unit testing. So this is technology stack, and there's a lot going on, but the first thing I would like to call your attention to is that it's a complete technology stack, all the way from the cloud, through databases, through APIs, pages, front end, and then user interface, a whole technology stack. And the reason I got interested in working on all aspects of the technology stack is because it's a whole system as far as I'm concerned, and if you're weak on one component, then the data is not at your fingertips as we aim it to be. Moving from the bottom of the technology stack upward, here we start with the storage. So a virtual machine. Moving up is Neo4j, and notice there's here this big block that is being labeled as BrainAnnex, which is open source, provides a lot of the functionality that a new website can just dip into initially, and then it can grow to do its own functionality in a way that's more specific to its own needs. But for starters, it's a great way to tap into relatively generic functionality without having to reinvent the wheel. Back to the stack here, that's Neo4j, that's the graph database. And by the way, no license is needed. This is just a community database, so you can have multiple versions and so on without paying a dime. Next, above it is a NeoAccess library. This is a library to make the database easily and powerfully accessible from Python. So if you're a Python programmer, you can write a script and you can do a lot of fairly typical operations without needing mastery of the query language, which is called Cipher. And it's the counterpart of SQL in a SQL database, but much, much more powerful. The next layer above it is a NeoSchema library. What's a schema? A graph database is just records, which are typically called nodes, and connections. And you could have totally senseless records with equally meaningless connections, unless you have some kind of mechanism to either enforce or at least encourage that the database should be in a particular form. The schema can be relatively lax, can be just a description of it, the typical way the data is, or it can be a more strict schema that enforces a lot. So there's a whole wide range, and you can decide how strict you want it to be. For example, This diagram represents the baseline schema that BrainAnnex comes with. This particular schema implements a multimedia content management system, which historically was BrainAnnex's original use case. As I mentioned earlier, this is no longer the case. BrainAnnex can be used for just about any purpose that's based on a graph database. But this particular schema comes with a version that ships out. The green nodes in the diagram represent classes. A class is essentially one type of record with a particular structure, so it's similar to a table in a relational database. The orange nodes represent properties, so basically fields, and the blue nodes represent data points. For example, this node right here, labeled root or home, represents a category, so essentially a page to which users can attach different types of content items being things like headers or media such as notes, images, documents, as well as records. Once again, this is just one use case of BrainAnnex, the one that historically it was developed for. You could change the schema to your own purposes and it could be totally different. Armed with the access library for Neo4j as well as a schema library, you can create an API request handler, which is basically Python code that uses calls to the library to fulfill whatever needs your API has. And the API that comes with BrainAnnex as existing open source software already includes a lot of stuff. For example, record lookup or modification or deletion. The API can also assist you with things like schema editing as well as import and export, so pretty wide range. You could, on your side, you can have your own API above and beyond using the existing one, so it's very expandable, it's very modular. To the extent you're happy with the existing API endpoints provided by BrainAnnex, you can just use them and that's the end of the story. But when and if you get to the point when you have something more specific, then you can make your own API. And then that API could directly tap into any layer here, like the schema library typically, or further below. So this part of BrainAnnex is served by Flask, a platform for the backend, and that comes in handy to provide templates for pages. You can have a variety of pages providing functions like record querying or viewing, editing, import, export, or pagination, or editing the schema, management of the database as well as login. So your pages can do all of that. A lot of those functions already exist in BrainAnnex. The site is not dependent exclusively on those existing pages. It can add its own pages. And Flask provides a convenient template mechanism, so you can create pages fairly easily. You just pass to them the data from the page request handler, which in turn creates whatever data the page needs by calling the appropriate Neo schema library or Neo access library. And then the pages, besides receiving the data from Flask, which is a less interactive kind of functionality, the pages also have the assistance of a variety of Vue.js components. Vue is a front-end platform, and these various components give a lot of interactive functionalities to the pages. Some of those are provided by core components, and they enable some of the functionality I talked about before. And also there's a number of plugin provided components, a way to expand the core functionality. Anytime you want to have something specific to a particular data type, you can add a plugin to BrainAnnex, or you can have a component on your own site, either way. And then finally, there's a layer of navigation to access all these pages, and then a browser accesses a particular port. So this is the BrainAnnex part. BrainAnnex is meant for research projects. There was a driving force behind it. And in many situations, a research project wants to get started quickly and is quite happy to use the existing functionality, even if it's relatively generic. And then by the time the research project takes off the ground, then it will gradually, most likely, add its own functionality whenever it is something much more specific for its own purposes.